This conference will now be recorded.
Hi, very good morning and good evening, everyone. Welcome back. So actually, I tried to launch a cluster. It got failed with some reasons, stating it cannot create a cluster because of because 1E, the target availability zone does not have any so sufficient capacity. Okay, so then so what I have to do choose is I have to move with other availability zones rather than that. So how can I do that is just give hyphen help. So what are the options I can choose about availability zones? Node zones. I think that is the one only. Okay, so hyphen node zones. So we give particularly some zones, like I will give 1D, comma 1F also I'll give. Name already exists, that is not deleted properly. So let me go with the test one. So this launches something like so something like Terraform it uses in the backend, so which it is called as cloud formation in Amazon. Amazon's cloud formation is nothing but an alternative to Terraform. It is that EKCTL uses its own so to do that. So you can just go to cloud formation. Cloud formation, and then here there is some test, basically the old one. It's actually saying delete in progress. That's okay. All right. So it just goes and creates certain, it just takes some time. Again, 10 minutes is gone. Okay, all right. So in the meantime, let me open my code. I think yesterday we were trying to talk about the health checks. So today we're going to talk about the resources. Okay, so yeah. So yesterday we tried to talk about something called as health checks, right? So now today we're going to talk about something called as resources. What is resources? So Kubernetes pods are capable of taking all the resources basically from the node. So this is actually a container property. So container, I already shown you on the container side also, right? On the containers, by default, they actually try to consume all the memory and CPU. Just to avoid that, basically you can give a certain amount of CPU and certain amount of memory. The same thing, okay, so applies to Kubernetes as well, because Kubernetes also uses the containers in the backend. And so the problem here is basically, so if one pod is actually, or one container is actually overutilizing the things which is unnecessarily, which is it is not supposed to utilize, okay, then it will cause a problem. So just to avoid that particular problem, so just to avoid that particular problem, so we wanted to use just to avoid that particular problem, we wanted to use resource limitations. Okay, so one container is actually or utilized unnecessarily, it cause problems for others. Okay, just to avoid that, so we're using resources. Okay, so yeah, when it comes to the resources, basically, so it supports basically min and max of min and max, which is called as requests and limits. So resources can be given as minimum, okay, and maximum, and those things are called as requests and limits here. Okay, so min and max, which is called as uh, requests and limits. All right, so this is how we are going to deal in Kubernetes. Okay, let's write some small YAML files. Also, another thing you need to understand here, which is your yeah. Let me show you how you do that. So I think this also is failing. Is that not the right option? Node Jones. Oh, here another Jones is there. All right, so here I am going to put like resources file. Kind is pod. Metadata name is test, and spec containers name. So probably let's say nginx, and then image is also nginx, and now resources basically requests, and like let's go with resources in Kubernetes. So CPU and memory. So CPU can be provided in millicore, and the millicore is like let's say one CPU, one virtual CPU is equal to 1000 millicore. Okay, let's say if I want to give 250 millicore, and I give that, and memory is basically like let's say 120 128 mi. Mi means megabytes. Okay, so millicore and megabytes or gigabytes, you have to provide it this way. Okay, so yeah, 250 millicore. So that means 1/4 of CPU I'm providing to that. And so limits, like sometimes it needs some beyond also. So you have given minimum requested is this. Okay, the minimum resources you get it over here. And if Kubernetes doesn't found any node with these resources, like it will never provision a pod. But later, sometimes while you go beyond, so what you need a little bit more, like let's say 500 millicore, and memory is basically is 256 megabytes. Now sometimes if you go beyond, okay, so the max I want to, okay, let's say due to some reason, due to some busy also, it's actually trying to go a little bit beyond. Okay, due to that busy, so assuming that assuming that you I mean to say like so assuming that you want to still give some more resources, what is the max you can provide? Okay, so minimum it will take that much, but there is no guarantee that you get max or not. That's a slight important point you need to understand. Okay, there is no guarantee that you get it. Okay, so that is the difference actually. Okay, so minimum you definitely get that for that particular pod, but maximum don't guarantee, no guarantees. If there is the resources available, it will provide. Okay, so cluster is coming up. Let it come up. Just takes another 5 minutes close to. Come on. Yeah, creation is a little bit lazy actually, the Kubernetes part. So in the meantime, so what are the other topics which we have here is today we're going to talk about there is something called as networking also. Health checks, resources, statefulness with mounts. Yeah, so these also will talk networking. Yeah. 217, 228, almost 11 minutes. So and also in the meantime, let's go with some theory. So these, so the containers actually I discussed, right? So it's basically it's ephemeral. Basically, that means if you lost the container, you lose the data, right? And sometimes you want to deal with some persistence. So how do you deal with in containers? We talked about that. The same way here, if you want to actually store your data, so there is something called as PV, PVC, and storage class. So we'll talk about those things as well. So what is a PV and what is a what is a PVC and what is a storage class? Okay, so PV is a large unit. Basically, you take a chunk of storage and you attach to your nodes and you want to use that. Okay, so that is a PV. Okay, so and inside that particular PV, you want to use small pieces for your requirement. So that's a PVC. Okay, so what I'm trying to tell you here is, so let's say your Kubernetes is running inside your own data center, and assume some storage is attached to your servers. Okay, and you want to import that as a storage into your Kubernetes. So that's where PV come into picture. Okay, so the administrators will create PV and provide it to you. Administrators will create a PV and provide it to you. And out of that, so you have to create some PVC, and you'll be using that particular PVC and map it to your pods and use it as a persistent storage. And when you go into a cloud, this PV concept is directly not needed, so you can go with the storage class. Storage class is what you're going to say that, hey, I want 10 GB of memory or 10 GB of not memory disk. I want 10 GB of disk. Automatically 10 GB will be provisioned. A PV will be provisioned and associated PVC also will be provisioned and given to you. So one PV of 10 GB and with PVC also with 10 GB will be created and provided to you using the with the help of storage class. That's it. Okay, so once you're in a cloud, so you kind of use storage class. But if you are actually doing the traditional, on-premise data center and the storage configurations and all, so you go with the PV. Okay, so these are the things which you have in this one. Practically, we'll see that so that we can have some, or it's basically saving some data. And how do you get the disks? Yeah, it's done finally. It's too much time. Okay, all right. So let me just quickly push the code. Okay, so ls cd kubernetes ls cd pods ls space pull. Yeah, so you got the pod created. So and ultimately, so the resources whatever you have is limited. So basically, if you want to give a try, you can just put the same stress way and you can find it out whether it is really working or not. Okay, so that is okay, and you know that how to do that. So probably you can give a try on that. So rather than Nginx image, you put CentOS, you can do that. Okay, or let me just go with CentOS. Okay, and CentOS:7. You should be able to do that, and ultimately it requires a command to run. So that's where I will go. Okay, so I'll go for sleep. So 10,000. And yeah, and let me kill the pod. So space pull. Cube cdl apply -f 06 resources.yml file, and you are okay. So yum, wait. So yum install epl hyphen release hyphen y. And yum install stress And so stress hyphen help. So you have this. So stress and hyphen VM, and probably 2 and VM bytes, and you can just give seconds. So now this will it's also not running. Why? Because the allocated memory is around 128 MB only, right? I think you just given 128 MB and 256 MB. Okay, so two times also it's not able to take it. Okay, so even though it is 256, it should be definitely some less around. So if you give one, it is suffocating. So that means 128 MB it is definitely having, because request is for sure it is having to 128 MB, but there is no guarantee that you get 256 MB. Okay, that is what you have. All right, so this is what you can do. This is how you can do the load testing basically. All right, so okay, so that's how you can do that. Let me come out, and yeah, the next one, so which is about using so 07 pvc.yml file. Now I wanted to create a disk, and I want to provision that particular disk in or not provision the disk, and create a disk, which is nothing but the provision the disk and mount that particular disk to the pod. Okay, how do we do that? So that basically API version, which is v1 kind, is a persistent volume claim. Okay, so first of all, so pvc Kubernetes, if you go there, pvc Kubernetes, you will find out examples. So persistent volume claims, and this is what you have, and you can see the storage class name you are going to provide. Okay, so first of all, if you want to check it out, kubectl get space storage class. Storage class is nothing but, as I mentioned, it's a cloud. Basically it is telling that so it is going to create some EBS volume. Okay, now what I'm going to do is I'm going to say that metadata name is so like, let's say MySQL, something like that. Okay, so or Mongo, anything is okay, MySQL or Mongo, whatever it is. And so you're just do this. Spec is this. So spec is telling access mode read write once, so that means it actually runs. It actually read write once means only one pod can use it at one point of time. Only one pod can use it at one point of time. Multiple pods cannot use the same volume. So that's what you're telling read write once. And volume mode, basically it is going to format the file system. So this is a file system, and so resources requests, like let's say 1 GB you're giving. Storage class name, ours is GB2, and you don't require the selector, basically it's fine. Okay, so you are actually creating a PVC. So let's push this. kubectl create apply -f 07 PVC. Okay, now in the PVC, if I go there, so you can see this, it's actually pending. Why it is pending? Because no one is really utilizing it. Okay, there's no point of creation. Okay, so a PVC has been reserved, that's it, but it's not created yet. Okay, now I can go back and say here, hey, I want this particular volume mounted to a pod. Okay, so then how do I do that? So let's refer the more examples here. So then you can find out how to attach to a pod. Okay, so then you can see this my pod, so which is basically MySQL. Okay, and MySQL basically is MySQL, basically image is MySQL, and here it actually var /lib/MySQL. Okay, so here it is MySQL, here it is MySQL, here it is MySQL. So you're telling that take a volume. So which volume? A persistent volume claim of MySQL. So this one, persistent volume of MySQL is this one, and take that. Okay, so give a name and map that particular name and mount it in MySQL here. Okay, so that's it. You're just telling this. I think this requires an environment variable to run. So env and hyphen name MySQL _root_password is a value is 1 2 3. Okay, so this is what the username and password I wanted to give. So let me push this code, and so now you can see this is actually trying to create a volume. Okay, it created one volume which is a 1 GB capacity, and if you go into Amazon and if you go into your EBS volumes is a 1. Okay, so and you can see this, you can find out, you see this is a 1 GB which is got created, so this is created by your Kubernetes dynamically whenever you need it. Okay, so now you can go to the pods and you'll see the MySQL which is still creating and now almost coming to running. Yeah, now you go inside shell, so MySQL -u root -p. Okay, so -p root 1 2 3. So now you go inside that, so show databases and create database. Okay, so which is like, let's say Raghu. Okay, now control quit and again exit here. I'm killing the pod, I'm not deleting the PVC, I just deleted the pod. I'm going to apply it once again. So now since I applied it once again, the PVC is still there, so that means the data is not touched, only the pod is got deleted and created. Now if I go inside that, so you will see the data. Now if you remove the PVC, you lose the data, so that doesn't make sense, right? Storage also, if you remove, like, you'll not have data. So MySQL -u root -p root 1 2 3 and show databases. You can see this, the Raghu database is still there. So that is where you're having persistent volumes. Okay, so I think that comes to the conclusion of the basic options whatever we use. Okay, so we go beyond, we go next to the next level options basically. Okay, so which is sets. Okay, so as of now you're creating one pod. Now we want to create multiple pods. I want to create a Nginx, okay, a pod, a multiple replicas I want to create, so that I can so scale up and scale down whenever it is needed. Okay, so that is the idea. So whenever I want to scale up and scale down, so I want to deal with that. Okay, how do I deal with this? Okay, so how do I deal with that? Okay, so that's what we're actually going to do now. And so let's talk about so how do you scale up? Okay, so let's go to sets, which is first one is a replica set. Okay, so usually we don't configure directly the pod in Kubernetes, by the way. Okay, so we don't actually directly okay, so usually sorry, so usually, okay, we don't directly configure the pod in Kubernetes. Okay, so then if we do directly put the pod in Kubernetes, you cannot scale. Okay, so that is the problem. So that's the reason, so Kubernetes offers sets, and we will be using those to set up the pods. So you have so replica set, stateful set, and daemon set. Now enhancing the operation to the replica set, we have deployments as well. So total 4, and we'll talk about one by one. So replica sets, let's start with replica set, which is a very important one for us, and we'll talk about that. Okay, so here first replica set is First replica set I'm going to create. So replica set in Kubernetes. It's quite simple only. It's basically it's as simple as this, like this. Just take this and replica set.yml. It's a replica set. It's a replica set. So probably I'll just call it as Nginx, and the labels you can say somewhere. These labels are important. Why it is important, we'll talk about that. And replicas actually currently will start with 1, and tire is Nginx. Tire is Nginx. So the same label I'm maintaining everywhere. Why? You will see that in a soon. And containers is Nginx. Container is Nginx. Okay. So this much I have. So cd dot get space pull. So now kubectl cd sets kubectl apply -f 01 rs dot YML file. Now if you see there is one pod which is got created. Okay, so because of replica set, so kubectl get space rs, so you can say that Nginx is 1 and your desired is 1, current is 1, and ready is also 1. Okay, now kubectl, so that's the reason one pod came into picture. Now I want more pods basically, so kubectl apply kubectl scale rs replica set Nginx -- replicas, okay, is equal to 3. So then automatically if you see down, actually 2 more pods actually getting created. See this? Okay, you can see that so 3 pods are actually getting created. So now if I don't want, I want to say 1 once again, so those 2 pods will go away, only 1 pod will remain back. So so you see the how scaling is too faster. You see the scale, you have already seen the scaling of Amazon, right? AWS. So you see how lazy it was. So you see the scaling of Kubernetes, how fast it is. Okay, so this is one of the major reason like people go with the application world around Kubernetes. Why? Because things happens faster here. Okay, so yeah, that is one thing. So now if you have like, let's say so I want to access this particular service, I want to access this particular service. So now I want to access this particular service when I have 3 replicas. If I have 3 replicas, it's like a 3 machines out there. So if you have 3 machines out there, so what is the concept you have applied in Amazon to so send the load to all the 3 nodes using a load balancer, isn't it? So the same way here. Okay, so I want to balance the load between these 3 pods. In fact, okay, I want to talk to this particular service. Okay, so so there are 3 pods. A service A talking to these 3 pods. We cannot talk to an individual pod because pod is again ephemeral. It can go anytime away. Okay, so during your scaling up, scaling down, your upgrades, the pods will continuously change, and those IPs also will continuously change. So that's where we'll never go with the individual pod reaching. So we'll keep one service in between, and from service only we'll always reach. Okay, so that comes to a service, but later we'll talk about that. So for now, actually what I wanted to do here is I want to talk about more options here, and the options here is so first replica set, if I give an image like let's say 1.17, okay, Nginx colon 1.17, it is there. Okay, so if I want to put this particular image, okay, now I push the changes. Now I'll just pull the changes, get space, pull, and kubectl apply -f. Okay, so 01 rs.yml file. Now you see this, basically only the replicas are getting changed because the replica actually configured here is 1, but actually it's not bothered about the one pod which is still running, which is an old image, it's not really bothering. So now I'll change one more version, like let's say I want to go with 1.16. So now I'll go with the git pull, and even if I apply kubectl apply 01 rs.yml, nothing will change here. See this? So the pod is still running, no changes are happening. But this is not how our CI/CD works, right? So if I need some changes, those changes should be implied. Okay. So now what actually does is, what a replica set does is, a replica set doesn't bother about any spec change of the pod. So replica set will never bother about any spec change here. Okay, which is a container spec. This is a container spec, and this is a replica set spec. Okay, so the container spec, any changes to the container spec, the replica set will not bother about that at all. Okay, so then I need to bother about that. Okay, so if I need some changes, I need to imply those particular changes into the cluster. So then okay, replica set is not the answer. So that's where the deployment comes into picture. So the deployment comes into picture. So in the deployment, you don't need to do super things here. So we just say, so the replica set changed to deployment. Okay, deployment, that's it. You don't have to change anything at all. So currently, let it push. Now git space full. kubectl apply -f 02 deployment dot YAML file. Now you see this one more pod also getting created, so which is a deployment pod, which is a deployment. Okay, now I want to say, so hey, I want 17 version now. So I made the changes, I push the changes. Now I'm going to pull the changes, I'm going to apply the changes. Now observe, actually automatically, okay, one more pod is getting created and the old pod will get deleted. Okay, it automatically creates a new pod and automatically deletes the old pod. So anything you want to bother about the container spec changes also, then you choose deployment, because replica set is not the one who handles that. Okay, so that is where you require a deployment, and that's where we choose deployment over replica set. Okay, but if you don't bother about a kind of changes, you bother about only the replicas, then replica set is also fine. And in fact, beneath the scenes, deployment uses also the replica set. Okay, let me show you that. kubectl get space deploy. Now kubectl get space deploy, so actually you're getting nginx deploy, right? So now if you just get deploy -o YAML, I just want to get it in a YAML format, all the things. Basically, it is going to tell you that it is using the replica set of this one. So it actually trying to use a replica set of this. So kubectl, okay, so kubectl get space rs. Actually you created only one replica set, which is nginx. Now it is trying to create two more. Deployment is actually trying to create two more replica sets. For the first configuration you got one replica set, and the old configuration, for the new configuration you got one more replica set. Now if you want to revert back, like let's say, hey deployment, I upgraded it but it's not working out, my product is not working as expected, I want to revert back immediately. So then what you are going to say, kubectl rollback. So kubectl deployment rollback. Okay, there's an option rollback. If you just go there, rollback a deployment version. So kubectl, this one, roll status. So rollout status of deployment nginx. If you just give this, so what it is telling, is actually having rolled out. No, not this. Rollback is the option. But how do I get the revisions? So kubectl rollout history, nginx. So you first see the history. Okay, there are 3 versions basically, 0, 1, 2. Okay, now if you want to go to a particular version, so then what you have to do, so if I want to go to a particular version, so then rollout undo. Yeah, rollout undo is fine. So deployment nginx to revision. Okay, so to the revision is equal to, so which revision I want to go? I want to go to a revision which is 0. Okay, So revision 0, if I go, it automatically rolls back, and again one more container comes into picture. Now kubectl get space rs, which is a replica set. Now you see this is the old one. So previously the old one is 0, 0, 0. Okay. Now the old one went on 1, 1, 1, and the new one went on 1, 0, 0, 0. So what happened? You made some change, and you don't like the change, and you want to revert it back. So reverting back is also quite simpler here. Okay. So that's where your so your deployment actually controls the replica sets. Okay. It just creates a replica sets according to your configuration, and based on your configurations. Based on your configurations, your replica sets will be modified, and so given you the number of replicas. So this also behind the scene, it's doing the same thing. All right. So this is how a deployment works, and the rolling strategy which is happening here is rolling update. Basically, rolling update means one by one, one by one. Okay, it's not blue green. It's basically rolling updates. Okay, so that's how. So we. Okay, we have daemon set and replicas to maintain the number of replicas. And what next I do have is okay, a daemon set and a daemon set and stateful set. So let's first talk about daemon set. So daemon set is something like so runs as a daemon on all the nodes. Now the replicas is designed based on the number of nodes you have. Okay, as per the number of nodes you have, as per the number of nodes are there, you want to kind of run the pods on the number of nodes. For an example, like let's say you take Prometheus. Prometheus is basically does what? Monitoring monitoring of your pods, but where your pods run on your nodes. Now I want to run everything I want to run everything on I want to collect everything on each and every node. I want to collect from each and every I want to collect from each and every node some metrics basically. Okay, so that means certain things which should run on every node. So those things also will be run as a pods, and it collects the information, and the replicas, number of replicas will be defined based on the number of nodes you have. You have 10 nodes, 10 replicas will automatically get created. On every node, one pod will run which collects the information about the remaining pods. Okay, that's where the daemon sets comes into picture. So for our Prometheus and all, we'll be using so the daemon sets. Okay, so let me show you a daemon set. So Prometheus daemon set. So here node exporter basically daemon set.yml. So there's already some predefined configuration. I'm just taking it. It's a big configuration. For Prometheus, you need to provide all the information. That's the thing. But yeah, so I'm just going to take this YAML file. I'm going to give kubectl apply. So kubectl create. So it's actually having so call download the file vim node -exporter.yml file namespace. You can delete this. Okay, only one line. So kubectl node -exporter.yml file. So it created a node exporter, and kubectl okay get space daemon sets. So now you can see this, the node exporter, the desired is actually 0, and this one, I think there's a lot of labels happening there. TL delete. Okay, let me take a look, like, so why it didn't got any pods created. So let it create it, and kubectl get daemon sets, and why it is not really happening. A node selector is there, which is OS is equal to Linux. Yeah, that is the problem. So let me just kind of modify that. So node selector. Wait. So let me go and apply this. So kubectl get daemon sets, and still it is 0. So it is kubectl. So describe daemon set. So describe is another option to describe that particular daemon set. It's actually telling that so error creating the pod. So node exporter hyphen forbidden looking for the default node exporter service account. Okay, so there is no service account basically. Okay, so ctl create SA, which is service account created, describe, delete, apply, describe. Now you got it. Okay, now you can see this, there is two node exporters came into picture. There is two node exporters came into picture. Why two nodes actually two exporters come into picture? Because there are two nodes only. So kubectl, okay, kubectl get space daemon hyphen sets. Okay, no hyphen. So it's daemon sets. So now you can see these two automatically came into picture. Why two? Because kubectl get space nodes. Okay, now if you increase one more node, automatically the another node exporter automatically comes into picture. So let me show you my current project basically. So how many nodes I have? kubectl is my local system. So kubectl get space nodes. So it's also Amazon same EKS. So kubectl get space nodes. So now you can see these many nodes I have. Now kubectl, okay, get space pods hyphen n, which is admin, and pipe for Prometheus. So you can see this Prometheus node exporter node, like let's say node hyphen exporter. So how many are there? So the same, so same nodes, how many I have, the same node exporters I'll be having. So those many. Okay. So whenever there is a node increase happens, automatically, okay, one more pod will be launched. So that's how the daemon set works. That's how the daemon set works. Okay, so that's about a daemon set. So to practice, that's okay, just understanding is fine for us. And the next thing, so which you have is a stateful set. So stateful set is what? Now currently you're creating nginx pod, and nginx pod is actually trying to get created, deleted. It's for a stateless application. So that means it doesn't store any data. Okay, so first thing is it doesn't store any data. But if you want to have some data, okay, inside your pod, like let's say MySQL, you have a database. MySQL, you have a database. So now whenever you have a MySQL as a database, and it needs to store the data. So now along with the pod, you need to have some storage also to be created automatically. Along with the pod, you need a storage also automatically to be created. And even if you scale down and scale up, your data should not get destroyed. Okay, so and such stateful applications, you go for stateful sets, and that's where so probably you can just go and do MySQL stateful set Kubernetes. Okay, so you can just go and get a stateful set of MySQL. Rather than this, we'll find out from Yeah. So this is the one, and you're actually trying to create a stateful set. Now will you see this automatically? So there is a volume also will get created automatically. You're just saying that, this one, and stateful set will automatically try to create that particular one. Okay, let's see. Let's just pull. And git space pull duelus qctl. So now this is getting created and is actually trying to go into pending. So let's go to PVC and let's go to the pods. So describe, it actually doesn't have any volume. Okay, PV claim. No, actually this is a wrong one. Just gave the stateful set but didn't give any volume. Volume creation. So there is another utility called as a Helm basically. Okay, so Helm is an installer package manager for your Kubernetes. Okay, let me go and take the approach of Helm. We don't write any Helm charts here, but we'll just consume a couple of them. I will just go with so the stateful set configuration using Helm. Okay, so Helm is something which is not installed, so sudo lab true, right? And Helm is something you have here. Helm 13. So there is a version 2 and version 3. Version 3 is the latest one, so I think you can forget about 2. So ls and so Helm space. So first of all, I want MySQL, right? So which is github.com/helm/charts table. This one is there. Okay, so these are the charts. So MySQL. So there is a MySQL here. It is, and it is actually deprecating, and it's been moved to some other place. It is telling. Or why do you worry? MySQL stateful set Kubernetes. That's it. Not Kubernetes anymore. It's actually Helm. Now, what is a package manager? Yeah, Yum is also a package manager. So then how is it related basically here? So what Yum does basically end of the day, you Yum install Nginx, it puts some binary file in /bin, it puts some configuration file in etc. Okay, it puts some, it creates some directories in USR Nginx. Like this, basically, it does couple of works only, nothing more than that. Okay, so here this package manager of this one also, you need to create one, you need to create one stateful set, you need to create some service account, you need to create some volumes. So all these things will be done in a single shot if you go with the Helm. That's it, nothing more than that. Okay, so Helm install Bitnami MySQL. Install MySQL and then Helm repo update. This also will not help. We need to set up the Bitnami. How to set up the Bitnami repo? It's like a yum repo. Okay, so you need to set the repo files actually to this. How do I do that? Need to see. Helm repo, add Bitnami, and this is the URL. Then only it will work. You add the repos and you view repo update, and you go and you install MySQL Bitnami / MySQL, and you get MySQL is getting created, and actually go to the PVC, and you see this data MySQL 0 automatically some 8 GB size is actually getting created. Okay, if for each and every pod you make it, okay, you kind of get one new PVC. So let me show you that. Yeah, so now that is coming almost to running, MySQL almost coming to running. Now I would like to go and give kubectl get space stateful set. Okay, you will find out MySQL. Okay, and 0 by 1 is there, and kubectl scale stateful set, which is MySQL -- replicas is equal to 2 if I give. So then the scale, the scale has been increased, but actually, immediately you're not seeing the pod because it's stateful set. Slowly it will happen. Okay, there is no hurry for, on the stateful set there won't be any hurries. Okay, now you see this, the MySQL 0 came to running. Now it is actually going to MySQL 1, and MySQL 1 you go to the PVC, so there is one more PVC also got created. So like this you are going to have so every pod is going to have its own storage, but end of the day these two pods are actually working as a cluster. MySQL cluster is actually trying to deal with the data which is actually it is holding. Okay, so this is how your stateful sets is going to work basically. Okay, all right, so we'll not much concentrate on these things, so we'll just go with the more onto the deployment side. So the deployment, actually we are going to make the images of our choice. Okay, so the rest of the things like RabbitMQ, MySQL, RabbitMQ, MySQL, MongoDB, all these actually is going to get created as a simple Helm charts in the backend. Okay, so only components will bother about is front end, and the other 5 components, cart catalog, user, and shipping and payment. So we'll bother about these services running in the CI/CD. Okay, so that is how we'll be proceeding actually further. All right, and so Helm space ls, so basically a list. So Helm space delete MySQL. So let's delete everything, and the pods, so everything gets deleted, and but the PVCs will not be deleted, so you have to delete them manually. Okay, all right. Yeah. So on the next thing, so which we have here is the services. Now let's say I have a deployment of Nginx, like let's say I have an Nginx service here. Okay, and I want to so access this particular service, so inside the cluster and outside the cluster. Okay, if I want to access inside the cluster, so there is something called as SVC. So inside SVC I need to create this one. So now VIM, or basically SVC, and over here new file. So cluster IP dot YML, cluster IP dot YML. So in the cluster IP, so what actually I'm going to do is I want to attach to this deployment. So how do I attach to this deployment? So here what I'm going to do is so API version question is V1. So kind is service. Okay, metadata name is nginx, and okay, so spec is so services in Kubernetes. I don't remember the exact syntax, so I'm just referring the documentation to do that. Okay, so selector. Okay, so selector. And so now previously with the load balancer, how are you attaching the nodes? By adding that particular instances to the load balancer, you do that. Now, once you put an auto scaling group, auto scaling will understand what are the instances it has and automatically attach to the load balancer, right? So now similar to that, so now here your load balancer, I mean, so the cluster or the internal service will be, it's like a load balancer only. It's internally how it attaches to the number of pods whatever you have is through the labeling. Okay, so here in the deployment, so you have some match labels basically here, right? So these particular labels, the selector labels will be matched with the service labels here, so which is tire is nginx, and it's also going to be 80 ports. So then now automatically it is going to find out all the pods with the selector label of tire nginx, then automatically it attaches to that pod. Automatically this particular cluster IP attached to that particular pod. So let me show you. So get space full. So kubectl get space svc, and you can see the svc, so here nginx and kubectl describe svc, and you do this. There is only one pod which is attached for now, so go for pods here. So only one pod which is attached, which is 40.201. See this 40.201. Now what I will do is a scale space, so kubectl so scale deploy. So which scale I want to deploy, which deployment I want to scale, nginx is the one, and hyphen replicas is equal to 2. So now you scale it. So another pod came into picture. Now your service also will try to understand, so kubectl describe svc nginx. So it automatically understand there is a one more pod which got created 12.207, which is at just 12 seconds back it created. Okay, automatically it attaching the second one. So like that, how many number of pods you scale it up, you scale it down, you kind of access it. But this nginx, the scope of this nginx service is only internally inside the cluster, kubectl get space svc. So then the scope of this particular one is only inside the cluster. If I want to make it outside, so then I have to go with so we have to go with so the same thing, same load balancer. So load balancer type in type is load balancer. Okay, nginx -lb. So the type of the load balancer basically tells is you create really a load balancer inside Amazon and serve these particular pods actually. kubectl apply -f this one. Now literally it is going to create one load balancer. Get space full, sorry, get space svc. It's literally creating one load balancer. And if you go to Amazon, it actually literally creating one load balancer. See this instances, it automatically attached all the instances however it has. Currently it is out of service. After once you get in service, then you will see the nginx web page, and that particular nginx web page is actually getting served from the pods. Okay, so that actually gets us into the architecture which we need to make it for our Kubernetes basically. So the same way, now I will be having so I'll be having a front end. So the front end also will be The front end will be exposed to outside world over a service. Okay, so and the service is let me put this some patch. So let me put this. So this is actually a load balancer type service. Okay, LBSVC. And whereas so now you go with the back components, which is actually going to be a catalog. And so this is so this is a cluster IP. So which basically I'm going to say as CIP. Okay, so now this front end will talk to this cluster IP, and cluster IP will go on so go with the remaining parts, whatever you have. Okay, so this also you have it, this also you have it. Okay, this also you have it, this also you have it. Okay, so here it is, card, user, shipping, and then payment. Okay, so this will talk to this, and behind the scene, anyhow, you will be going to through Helm charts. You are going to make MySQL, Mongo, what else? RabbitMQ, and even Redis all comes through, so automatically, so all CIPs only, by the way, cluster IPs. Okay, so and internally this also will connect. Okay, and once after we set up this, okay, so then we are going to talk about how do we do the CI/CD basically. So tomorrow we're going to start with setting up our cluster using the Kubernetes approach. And that's all from my side for today. Any questions? I think this is done. We can probably, you are saying welcome to Nginx, which is coming from one of the pod. Yeah, all right. Any questions? I'm going to delete the cluster and probably will meet in tomorrow's session. Okay, so we're not going too many internals of Kubernetes. So you already know that, so we are actually trying to do only the CI/CD effort of Kubernetes only. So that's where I'm not talking about deeper soft stateful set or daemon set. So certain things I'm not really necessarily talking about that. So what is needed for me? So we're actually trying to derive from that area only. Okay. Yeah. All right. So, but we'll do log collection. We'll do metric collection. Okay, so we'll put some load onto the cluster and we'll see how it is performing. Okay, so see you in tomorrow's session then. Bye. Good day.